Welcome to SK University. Today's illumination is the Encelium Extend Lighting Control System wired components from Osram. In a previous illumination, we've looked at the wireless components of the Encelium Extend Lighting Control System. This included a number of different types of luminaire controllers, wireless wall stations and their wired counterparts, wireless sensors, a wireless plug-load control module, and a wireless demand response interface. These devices send data to or are controlled by the wireless manager. Wireless managers communicate with each other via the Ethernet backbone, and that is also how they communicate with the SSU, and how the SSU communicates with other building systems, and with computers on the network running Polaris or personal control software, or through the internet to remote computers. We've seen in previous illuminations how we can tether some wired devices to luminaire controllers using green bus 2 connections. Those luminaire controllers have a single green bus port to support the tethering of one wired device, such as a wired wall station or the phase cut dimming module. When used for tethering, the maximum length of a green bus run is 20 feet. In addition to tethering, Green bus is also the network that we use to power and communicate with wired devices in larger wired installations. The Green bus 2 network utilizes 18-gauge unshielded 2-conductor cable. When used in a wired or hybrid installation, the length of a particular Green bus 2 cable run is determined by the voltage drop of the run based on the connected devices, but 2,500 feet is generally the maximum run length. Both pre-terminated and bulk cable options are available. By default, the system will be laid out as a daisy chain, as this is the least prone to wiring error and is easy to implement as nodes have 2 connectors for the network. However, the robust network is both topology and polarity free, so installers are free to implement whatever topology is necessary. Just as we have a wireless manager for our wireless devices, we have a wired manager for our wired devices. Like the wireless manager, the wired manager connects to the rest of the system via the Ethernet backbone. We can use as many wired managers as we need. Each manager has 8 green bus ports, and again, the number of devices per channel is determined by what types of devices are on each channel and their power consumption. Let's add a wired manager to our system by connecting it to our Ethernet network. Now we have a hybrid wired and wireless system. Now let's look at our options for wired luminaire control. We've already seen the phase cut dimming module and how it can be tethered to wireless luminaire controllers to allow for control of loads that require phase cut dimming in a wireless system. It can, of course, be connected to a green bus network that originates at a wired manager. An option that we haven't seen before is the Luminaire Control Module, or LCM. This module can switch 4.5 amps and is typically installed 1 to a luminaire. It receives its internal power from the green bus and provides a contact closure to switch luminaire line voltage as well as a 0 to 10 volt dimming output. We also have the Area Lighting Controller. Like the wireless Area Lighting Controller, this module is intended for control of a group of luminaires and can switch a 20 amp circuit and drive as many as 30 0 to 10 volt drivers. The Dual Relay Luminaire Control Module can switch 2 loads and is intended for A/B switching or step dimming applications. It does not have a 0 to 10 volt dimming output. The Dolly bridge allows the use of Dolly and Dolly version 2 ballasts or drivers with the system. Each channel of a wireless manager can support up to 64 Dolly drivers over 1 or more bridges for a total of 512 Dolly drivers per wired manager. The Dolly bridge and power supply mount on 35mm DIN rail, which is suitable for mounting in a NEMA metal enclosure. Each power supply can support as many as 4 bridges. The relay panel is an addressable lighting control panel that fully integrates with the system. Multiple panels can be daisy-chained as part of the overall Extend architecture through the Green Bus 2 communication network. This is the perfect solution for centralized applications where individual fixture control or dimming is not required. The Relay Panel module is an electronic retrofit module that enables existing relays and panels to be integrated with the system. It replaces existing relay control hardware and is useful in retrofit applications. The Sensor Interface Module, or SIM, is what we use to connect sensors to a wired system. The SIM automatically configures itself based on what type of sensor it is connected to. Occupancy and photosensors do not control lighting directly. The SIM reports sensor status back to the manager via the Green Bus network, and the manager determines what changes to make to the lighting loads. The SIM can also be used to take in contact closures to the system, offering a simple means of interfacing with other building systems, such as fire alarm and security systems. The SIM is compatible with most low-voltage 3-wire occupancy sensors that are available from numerous suppliers. Encelium also offers a broad occupancy sensor lineup that encompasses ceiling, wall mount, and wall switch styles in both PIR and dual technology types with numerous available coverage patterns. Parameters such as sensor timeout can be adjusted in software, eliminating the need for manual adjustment at the sensor. Photosensors for indoor, outdoor, and skylight applications are available with application-appropriate sensing ranges. In previous illuminations, we've looked at the wired and wireless wall stations that are available to us in a variety of configurations and the optional button kits that can be used with them, so we won't rehash all of that here. There are, however, some additional user interfaces that are available to us in a wired Extend system. For industrial and vandal-resistant applications, we have the industrial push-button and key switch options that come in stainless steel. The push-button connects directly to the Green Bus network. The key switch connects to the system through a SIM. We also have color touchscreen panels in 7-inch and 3-inch form factors. They provide the ability to recall lighting scenes, adjust color temperature, and shade position. This is ideal for large multipurpose spaces where lighting requirements vary throughout the day, such as an auditorium or conference room. With the intuitive panel design, users will be able to easily command various lighting scenarios to achieve a desired atmosphere. Let's visualize what this looks like in our building. We have our Ethernet switch and the Ethernet backbone network. Connected to it is our SSU, which also has a connection to the Internet for remote access. We have Polaris and personal control software running on computers on the customer's data network that are tied into the lighting control Ethernet network through a router. Our wired managers are also connected to the lighting control Ethernet network. They provide us with the Green Bus network to communicate with our wired devices, like wired luminaire controllers. We can also use the Dolly bridge to control Dolly driver-equipped luminaires. There is also a relay panel switching multiple 20-amp circuits of interior or exterior loads. We're using sensor interface modules to bring in occupancy and photosensors. We have wired user interfaces like wall stations and touchscreens. And since this is a hybrid system, we've got the wireless devices that we've seen before, with the wireless manager connected to our Ethernet network, managing wireless wall stations, wireless sensors, and wireless luminaire controllers over a Zigbee mesh network. That wraps up our discussion of Extend wired components. Thank you for spending time with us today. We hope you found this illumination helpful. If you have any questions or would like additional information, please contact your SK & Associates salesperson. Have a great day.